Hello everyone, welcome to CSE Core Concepts in the Computer Network series. In this video, I am going to discuss about a high level data link control protocol that is popularly known as HDLC. Now what is basically HDLC? It is a part of the data link layer protocol and it helps for linking communication, and it also applies the ARQ techniques for performing full duplex communication. So what is a full duplex communication is that when both sender and the receiver can communicate to each other at the same time, means the sender does not have to wait for the receiver, means both can use the channel at the same time, and these channels are very high flexible and reliable network structure. Now let us get started with the HDLC protocol. So basically, to apply efficiently integrate and use this protocol, we are categorizing the stations into three parts. The first type of station is called as a primary station. So primary stations are those which are responsible for controlling the operation. So generally, if a station is identified as a primary station, then the frames which are issued by these stations are generally understood as commands. That is, they are giving some sort of command. Second type of station is the secondary station, which operates under the control of the primary station, and the frames which are being transmitted by the secondary station are categorized as the responses. So the primary station gives the command and the secondary station gives the response. The third type of stations are called as the combined stations. Combined stations, they have both the features of primary and secondary. That means these type of stations can issue commands also, and they can give the responses also. So let us see the operations. So it involves first setting up the communication link. So two types of link configurations are there. First type of configuration is called as a unbalanced configuration, where there is only one primary and there can be one or many secondary stations, and they support both type of connection, that is either full duplex or half duplex. The difference between full duplex and half duplex is that in full duplex, both the stations can send and receive data at the same time, whereas in case of half duplex, one station can use the channel at a time. Okay, either they can send or receive, but only one at a time. So this type of connection is called as an unbalanced connection, where there is only one primary station but there are multiple secondary stations. So one station is only giving the command, and all of the other stations, it can be one or multiple stations can give the responses. The second type of configuration is called as a balanced configuration, where there are two combined stations. Both of them are combined. Both of them can either issue commands or send responses, and they are connected via either a full duplex line or a half duplex line. Now there are transfer modes. Okay, various transfer modes. The transfer of data between them are categorized into different types of modes. The first one is called as the normal response mode. Okay, so what is a response mode? So normal response mode. So it combines primary and secondary station in a point to point, or you can say a multi-point network, and to exchange commands from primary and response from secondary. So it is a very normal type of a mode, where there is one primary station, one secondary station, and it is a point to point connection, or you can say multi-point, means this station primary can be connected to other secondary stations also, and they are sending commands and responses. The next type of mode is the asynchronous balanced mode. In this transfer model, combined stations are installed point to point configuration for exchange command and in response of the balanced format, right? So you can see that this is a combined station, this is a combined station. Either they can send a command or a response, they can send a command or a response. So that is very balanced. And the third one is called as the asynchronous response mode, it's used with an unbalanced configuration. So what is an unbalanced configuration? When there is one primary station and one or more secondary station. So secondary may initiate a transmission without the permission of the primary. Here it is little bit awkward. So here the secondary may initiate the transmission without the permission of primary, but still the responsibility for the line is for the primary. That is, primary station will initialize error recovery, disconnection, everything is the primary station's responsibility. But the only thing is that the secondary can also initiate. So it is also called as the asynchronous response mode. That is, the response station can initiate. So let us see the HDLC frame. Okay, how does it look like? So it is a data unit for sharing the information. This is called as a HDLC frame. So there are multiple free fields which you can see. The first field is the flag field, next is the address, control, payload or information, FCS and the flag. So what is the flag field? See, when your data is traveling, there is a series going on. Series means 1 0 1 1 0 1 0 1. Now the whole series is going on in the communication line. Okay. So now how will you understand where is the starting of one frame and where is the ending of another frame? So to understand the starting and ending of each frame, you need to have a flag variable, flag data, right? So this flag is nothing again but a number of data series only, bit series only. So they will tell you that this is the starting of a frame and this is the ending of a frame. Understood? So every frame has a starting or ending, and it is nothing but a 8-bit octet sequence, and this is the sequence. So it starts with a 0 and there are 1, 2, 3, 4, 5 and 6 ones, and then again a 0. So this is whenever you encounter such a pattern, you understand that this is a flag field. So this is the starting of a frame, or it can be an ending of one frame. When you have two consecutive flags, one after the other, then you understand that this is the ending of one frame and next flag is the starting of the next frame. Next comes the address field. So address is encapsulates the receiver's address, because you are sending the frame, right? To whom are you sending the frame? So that receiver's address has to be there. So now if you are sending from the primary station, so obviously the address will be of the secondary stations, okay, to whom you are sending the command. And if this frame is of a secondary stations, then the address will be for the primary station, means it is giving the response to the primary station. The third field is the control field. This gives the flow and error control information in byte format. So any type of flow control, error control, any type of data to check the error, so that type of field. Next contains the payload information, that contains the information from the network layer, and the data size may vary depending on the type of the network. Okay, all the information which is coming from its previous layer, that is the network layer. Then comes the FCS field. It is for frame check sequence. So we have already studied about the error detection and the correction techniques. So where we have studied about the CRC method, where we do generate a checksum. So these type of checksum fields which you are generating for error detection and correction, so that value is stored in this FCS field. And of course the final is the flag, that is the ending of this frame. Okay. Next we will understand the different types of frames. How many types of frames are there? One type of frame is called as the I-frame. I-frame is also called as the information frame. So it is applied to encapsulate the user information. So whatever information it is getting from the upper layer. What is the upper layer? Network layer. So whatever data it is getting from the upper layer, which it has to transmit in the network, so that comes in your I-frame. Understood? So see, this is a frame, right? So this frame can be a I-frame and other frames which I will be discussing right now. So if it is an I-frame, right, then it will start with 0. Understood? So if it is an I-frame, how will you recognize that what type of frame it is? It will start with a 0. Then comes your S-frame. S-frame is called as the supervisory frame. So they are used for error and data control. They do not contain any information. They are used only for flow control management, error control management, right? And they start with the 1 and 0. And the third type of frame is the U frame. U frame is also called as the unnumbered frame. They are used for system management and controlling information between the network devices. Okay, so to communicate between two network devices, to check for the connection, to do some management. So these types of frames are called as unnumbered frames, and they start with 1 1, right? See, you can see here, this is the control information, this is the user information, and this is the system management frame, right? So there are three types of frames. So how does the HDLC operation takes place? Let us see. So basically what happens in HDLC? Two stations communicate. Now what can be the two types of stations? The stations can be of primary type, secondary type, or they can be combined stations. Now what are they exchanging? They are exchanging some frames. Now what type of frames can be? The frames can be information frames, the frames can be supervisory frames, the frames can be unnumbered frames, right? This is what they are exchanging. So basically there are three phases of the operation. The first phase is the initialization phase. That is, you have to first initialize the communication, right? So you have to request for that. So either side, if it is a combined station or any other station, they have to request that I want to start issuing the commands. That is called as initialization. So they have three purposes. It signals the other side that the initialization is requested. So initialization frame, when it sends, it will say that I want to initialize a communication. Then it will have to tell that what type of communication I want to do, which mode. Normal response mode means normally we will talk that sender issues command, receiver responses and all. Asynchronous balanced mode or a asynchronous response mode. So what type of communication we have to do. Then it will tell the initialization, during that time only we have to tell that how many sequence numbers we are going to use. If it is a 3-bit sequence number, then the window size will be from 0 to 7. If it is a 7-bit sequence number, then the window size will be from 2 raised to the power 7. That is all. Okay. So that value you have to compute, and that is the window size, right? Okay, then 256, let's say. So 0 to 255, right? So if the other side accepts this request, so when you have initialized and the other side is saying, okay, I can, okay, so it at the it will end on that end, it transmits an unnumbered acknowledgement frame backing to the initiating. See, the initialization who has done, he is sending a request to the other party that I want to start a communication. Let's say source A and B. A is initializing. So when it is saying initialization, it will tell which mode I want to, it will tell the sequence number, and if the station B says yes, I want to initialize, I want to talk to you, so B will send a unnumbered frame stating that yes, that is what is management, right? It is saying that yes, we can communicate, and if it rejects the request that no, I don't want to communicate, it will send a DM frame, that is disconnected mode, that I don't want to initialize. Then suppose it has initialized and the connection is established, then they will go for a data transfer. So when there is a data transfer, then a logical connection is established and both will begin to send the information frame. Data is what? In the information frame. So information frame is always starting from the sequence number 0, this we have discussed, and it will send the frames, and all frames will have a number modulo 8 or 128, whatever, whether it is 3-bit, 7-bit, whatever you say. So that way it will be done, and place the sequence number ns in the frames received or sent. Okay, so it will be sending is the acknowledgement of the I frames received. So you can see here, so we will go proceed. So we have a field called as the ns. Ns is what? It is the number of frames which has been sent, and nr is the number of frames which has been received. So in the sequence number field, that in that field there will be 2 columns, 2 flag bits, that how many number of frames has been sent and for how many frames we have received the acknowledgement. So this is been kept a track. And then comes the receive ready frame, RR frame, which is acknowledging that I frame has been received, that we have received. Understood? So station A has initialized a request, B has accepted it and it has denoted it using an unnumbered frame. Now both will be doing a data transfer. Data transfer means exchange of iframes. Now exchange of iframes means every frame will have a sequence number. The sequence number can be will be like 0 to 7, 0 to 128, whatever, depending on how many bit number you are using. And in the NS and the NR, these are the two fields in the sequence number, where it will NS means how many frames has been sent, the number, because every number has to be kept track, and NR field will keep your value, that how many frames acknowledgement has been received. So once a frame has been received by the destination, it will send a RR acknowledgement that I am ready to receive the next frame, and this way they are carrying out the communication. And if the destination is not not possible for it to receive the next frame, it will send an RNR acknowledgement frame, that means receive not ready. I hope you have gone through my earlier videos where we have discussed about these acknowledgements, that is RR and RNR. So RNR, it will send R. Now reject will include, now then again the same acknowledgement. Now suppose some frame has been lost in transit, so it will send a reject frame. So now if it is rejected, so it can use the go back in ARQ, where it can retransmit all the frames from where it has been rejected. Or let us say selective reject can also be used to request for a retransmission of a single frame. Understood? So any type of ARQ technique can be used. And the third phase is the disconnection. So when they have done with their communication and data transfer, so either of the station can initiate a disconnect frame. So it can say, or even if they have not finished the data transfer, if they can feel that there is some sort of fault or some problem is there also they can release the connection by sending a disk frame. So this disk frame is also say let's say station A has sent a disk frame. So this disk frame has to be acknowledged by an unnumbered frame saying that yes, we will terminate the connection. So any outstanding unacknowledged will be lost. Their recovery is the responsibility of higher layers. Let's say after sending frame number 5 to 10, and then station A and from 5 to 10 has been sent to the receiver B. Okay, B has sent the acknowledgement up to 8th frame. 9th and 10th is still pending, and meanwhile station A says disconnected, and station B also accepts that disconnection. So two unacknowledgement frames has been pending. So that is the responsibility of the higher layers, means the network layers. So I hope you understood about this important protocol. It is a very, very important protocol to initiate a communication between the two stations. So don't forget to like, share and subscribe to CSE Core Concepts. Thank you.